So today we are dealing with more fraction, decimal, and percent values. So remember that if you are going from fraction to a percent, you multiply it by 100. If you're going from percent to decimal, we divide by 100. Likewise, if we're going backwards, we take the decimal value and multiply it by 100. Or to go from percent to fraction, we put it over 100 since percent means divide by 100. Now, one of your peers had put up a really great question. So hopefully you guys are paying attention to your notifications as things pop up and tell you what's been going on in Schoology. Because in the Help Me folder, and this, they kind of put it in the wrong location. But in the Help Me folder, there's a discussion board that says, like, ask me anything about math. Really, that's supposed to be like questions that don't have any other place to go. So they could have put these into the Chapter 6 discussion board, and that would have been a little bit better. But so Lily put up here that she didn't know what to do on question 2 of 6.3, and that was asking which process represents conversion from a decimal to a percent. So I didn't even put the multiple choice answers, but I was verifying, like, is this the question you're talking about? So then I go through, like, why it is we do all of that. You got to remember that percent means for every 100, or out of 100. So if we check hard drives and we found out that 6 of them out of 30 are defective, that's not an out of 100 value. That's out of 30. So I do the math and I find it's 0.20, but that's a rate. I then take that rate and multiply it by 100. That's actually the answer that she was looking for, is you multiply by 100 and put on the percent sign. So that becomes 20%, which tells me 20 out of every 100 will have that issue or that defect or that trait. So pay attention to these discussion boards. Flynn asked something, Derek asked something. Other people then on the Chapter 6 discussion board, there's activity going on there as well. So please pay attention to your notifications page up here. But all of that for Schoology, that's as much time to take today. Any questions from yesterday's video lesson? Sorry that I wasn't here. You guys know why I wasn't, so please accept my apologies for not being here. Adulting is not always fun. Yeah, Izzy? The dinner one? Lunch? The what? So grab out your notes from yesterday. Anyone need them? They're over there. We have extra copies if you don't have them still. So this is asking that a school made an estimate. So let me try to relate this to Phoenix. If we estimate, let's say, so we're doing, we just had the garage sale, right? And actually we just got word that our total profit made off the garage sale was $6,500, which is pretty sweet. It was not our goal, but it's tough to have a fall garage sale because people aren't really in the garage sale mode in fall. Most people do garage sales in the spring. So we just had our garage sale, but let's talk about expenses. We have to rent a U-Haul that we go around and we pick up donations with. We have to pay for tape and all these things that we have to use. We use markers. We use a cash box. So we've got expenses that we have to pay. So this school is having a fundraiser, and they expect that their expenses will be 3.25% of the money they collect. So this of tells me to multiply. So they collect $16,000. So if their estimate was true, we could calculate our expenses by saying 3.25%, which this would become 0.0325 when I do the percent divide by 100. So 0.0325 times the amount that they made, the 16,000. So their expenses, awkward decimals, you're more than welcome to use a calculator. If their estimate was true, their expenses would have come out to be $520. But we see that after expenses, they only have $14,500 left. So how much did they pay in expenses? Well, if they had $16,000 and now they have $14,500, how much did they pay in expenses? Xavier? 1,500. Are these the same value? No! So their estimate was off. Their estimate was way off. Now, if we want to take this a step further, the question does not ask for this, but if we want to say what percent were the expenses, anyone know how to calculate that? How could I find out what percent the expenses actually were? Abby? Well, I want to know how. Like, how do we calculate this?
Because you do 520 divided by 100.
But that wasn't their expenses. 520 was their estimate. So this value, the 520, doesn't even really matter. It was just what they had thought their expenses would be, but they were wrong. Nope, close. We got to do a division, but to find a percent, it's always part divided by whole, right? So do you know what my part and my whole are? How much were my expenses? Is he? This is what our expenses actually were over the total that my fundraiser made. I do that division, and I'm going to get just under 10%. Anyone have this? Anyone have a calculator handy? What do you get, Shane? 9.375. So that when we turn into a percent is 9.375%. So their real expense percent was a little over 9%. So for every, this is where we use percent, for every $100 they made, how much did they pay in expenses? For every 100, percent means for every 100. So for every $100 they made, they paid approximately $9.38 for expenses. Because this means for every 100. So this number is the for every 100 number. So for every $100, they paid about $9.38 in expenses. Any questions on that problem? Sorry, go ahead, Abby. That's every $100. So if they made $100, they paid $9, a little over $9 in expenses. They made another $100, they paid another $9 in expenses. But that's not, they didn't actually pay expenses every $100. I just want you to understand why we use percent. It's for every 100. Any other questions? Please ask. Did you say nigh? Nigh. That whole no soccer thing. Yeah. Or 9, like German. German, it's 9. All right, so today we are going to move on into 6.5. Do I have any volunteer note passers? I mean, come on up. We'll split them up. Whoever wants to come up here. I don't care. The more hands, the quicker it happens. So guys, just make sure that the extras all land. Hey, note passers. Make sure the extras all land right here in this M7 bin. Did somebody already? Or you just grabbed yours? Yeah. All right, we got to move quickly today, so I need your attention. We are having an origami contest.
Yes! Wait, I don't know how to do this.
So, we're not really. This is just a math problem. We could, if you want to, make a club. So we're going to have an origami contest, but the issue is we give them a certain amount of time. Hey, Joe, you with me? We give them a certain amount of time to fold their origami, and not everyone folds the same amount of origami. You've got your happy friend, your surly friend, some new friend that you just met, and somebody you don't know. They're not your friend yet. So, your happy friend folded 12, Surly 10, 8, 15. But they all have different amounts that got folded perfectly. So your happy friend folded 8 out of 12 perfectly. Your surly friend folded 6 out of 10 perfectly. So if the judges are like, well, crap, we should have thought about this. We should have all had them fold 10 and then judge based off that. But we didn't. So how could the judges compare these people to each other? Since they can't just compare 8 to 6, that's not a fair comparison. Or neither is 6 to 4 because they had different total amounts that they folded.
Yeah.
Andrew, what do you think? I could use percents! Yay! Math to solve problems! Sometimes I'm being extra cheesy because I know you guys think I'm cheesy. So that's fine. But seriously, this is where math comes into play of like, you have to know how to rate people against each other. How do we do it? We use percents. So my happy friend, I would do the 8 divided by the 12. Anyone know what that reduces to? What can they both divide by? Ooh, what do you got, Anthony? 4. So divide by 4 on top, I get 2. Divide by 4 on bottom, I get 3. 2/3, if you haven't memorized it yet, is the 0.6 repeating, which comes out to be, if we round, we're going to round to the nearest percents. We'll go 67%. He folded 67% accurately. Now, that would be 66.6 repeating forever, but sometimes we just round to the nearest percent. Lily? It doesn't matter. If you repeat 2 6s or 1 6, you're going to have the same number. Not 0.67%. If you wrote the rate, it would be 0.67.
So wouldn't it be 0?
We multiply by 100. When we multiply by 100, my decimal moves 2 places.
Oh, okay.
My surly friend, we should know this immediately, Justin.
Yeah, he did 60%.
60%, because 6 out of 10 becomes 6/10, which when you multiply by 100 becomes 60. Xavier? 4 out of 8, we see that's half, and that's 50%. Then 10 out of 15, Abby?
Wouldn't that be like, it's hard to say, wouldn't that be like 45% or something?
Oh, we gotta either turn it into a decimal or reduce it down to something we know. Colin?
Reduce it down to 2/3.
Ah, that also becomes 2/3 by dividing by... Ooh, no,
Sorry,
not the...
2, sorry. 5.
We divide by 5 to get down to the 2/3.
And then you make that into 66. So 66% basically.
Yeah, we have the same thing, so it becomes that 0.66 repeating forever, which we round up to 67. So we have a tie. Now, here's the thing. If you were the judge and you had to break the tie, we now have 2 contestants with the exact same percentage. Xavier, how would you break the tie? You didn't expect that was the question I was going to ask?
No, like, at first, I was going to say
CJ, how would you break the tie?
I would pick the not friend because he did more origami in total.
Because they have the same percents, we could then compare, well, what was your total? Like, how quickly can you fold these origami? Because their percent was the same, I can compare their totals, and the person who's not your friend, they had the most origami and the best percent. So if I was the judge, I'd say they were the winner. I saw your hand the whole time. You don't have to keep waving it like I'm not going to see it. What's up?
Like, the only thing is, like, how would they have, like, the same percent if, like, the not a friend, like, had 5, like 5 more of the ones that weren't folded perfectly, but the happy friend had, like, 4.
So if you're thinking about the percent they messed up,
Yeah.
chill. I'm trying to decide if you guys can sit beside each other on the seating chart, because we have to make one eventually.
Can I sit here?
Shh, calm down. The more you talk to each other, the more I can't put you together. So if you want to sit beside each other, chill. We're talking about comparison of accurate to not, or accurate to total, part to whole, right? So it doesn't really matter about the fact that they misfolded 4 and they misfolded 5, because we look at what they messed up. This would be 4 out of 12, which comes out to be a third. This would be 5 out of 15, which comes out to be a third. They both messed up a third of their foldings.
Maybe I just got confused because they're both like different numbers.
So yeah, it's a different amount, but it's
Yeah.
the same percent.
I get it now.
Okay, sweet. Yeah. I'm not going to make you make, I will never make you make determinations that have any sort of bias in them. So my bias when I chose the not a friend is that he folded them faster. But maybe the judges would just say, well, you both win. Like, so really, if this was on a test, you would just say the happy friend and the not a friend have the same percentage. That would be the result that we're looking for. Other questions? So a reminder on how we do our fraction decimal percent conversions. When you have a fraction, let's say 581 out of some 1,932 students have curly hair. We're going to say, okay, well, what would that be as a rate? Well, to get the rate, we just do the division. So I do my division, I get 0.30, which actually, this is not the proper ... There would be more numbers out there. They're saying there are other numbers, but they don't really care about them because they only want the percent rounded. So we could take this a little bit further, but they find out that 30% of students have curly hair once they did their division, because to go from decimal to percent, and you might want to write this here, all we do is multiply by 100. And this means 30 out of 100, that's what your percent means, out of 100, have curly hair. Yeah. Because we rounded, we are approximate, but we're pretty darn close. When you round to the nearest percent, that's pretty close. Now my brother-in-law, who's an accountant, if I haven't talked about this yet, talks about the rounding dangers in money, because a lot of financial transactions get rounded to the nearest dollar or the nearest like 100 or something like that, because there's like, if you round up on some and you round down on others, you think it'll balance out. But when he worked for Maine Medical, which is a big hospital system up in Maine, their rounding errors at the end of the year, when you put all of them together, and the errors, like they knew these errors were happening, they were okay with this because it just made their math easier, ended up around $1 million in rounding, like money kind of that just like disappeared in rounding. And that was fine. They were perfectly fine with that because of how many transactions. So that's like pennies or maybe a couple dollars per transaction rounded off, but the amount of transactions that happened, that rounding ended up totaling over $1 million. Big medical system. So be careful with your rounding. It can get you in trouble sometimes, other times it's great. So we have a lot going on with our presidential election right now. To win the election, this is why I'm not talking about the current election, to win the election you have to have more than 50% of the vote. Or, what's more than 50%?
51.
Well, okay, yes, but what do we call that? It's the, starts with an M. Majority, yes, thank you. So you need the majority of the vote of the Electoral College, because actually the popular vote kind of sort of doesn't really matter. So the Electoral College has 538 votes, and please don't, when I was a kid, I was like, wait, is that a college? No, it's just called the Electoral College or the Electoral Panel or whatever people call it. They have 538 votes, and those are divvied up to the different states, depending on the state size based on population. So, in 76, and we looked this up, so I think this is like, this year is wrong, but this year doesn't matter because it, like, the year is an extra number. Guys, there, as we go into math and get deeper, there are oftentimes numbers in the problem that don't matter. I call these distractors. They're in there to distract you from what numbers do I actually need to use in my math. So, Ford got 240 of the electoral votes. We want to figure out what was Ford's percent. But we're not talking about people. We're talking about from the electoral votes. So when I go to calculate my percent, I'm going to do part divided by whole. I should see everyone with a pencil in their hand writing this down. That's going to give me 240 for my part of votes that Ford got. What's my total? What's my whole? Yeah, Jack? Hayden? 538. I knew you were going to say that as soon as somebody else went for it. Have confidence, man. What's the worst that happens if you're wrong in here? You're wrong. And we're all like, oh, by the way, did anyone do 6.6 yet? Homework? If you did, I owe you an apology. On question 5, and I fixed it now, so your grade will reflect that I fixed it. On 6.6, if anyone tried it already, the question asked about car lot. By the way, I have a heart condition, so if I realize that I've forgotten to take my pill, I at some point normally remember. All I have to do is take a pill twice a day for the rest of forever. That's how they deal with my heart thing. So, thanks. It doesn't affect me really at all. It's, if you're curious, it's called supraventricular tachycardia, which is really, really hard to spell. So, in that problem, it says you take your car to the shop, and the shop estimates it'll cost $80 to fix it. The shop calls you back, tells you it will actually cost $120. What's the percent error? I had the wrong answer marked, but I fixed it now. So if you already did 6.6, your grade will have changed itself because I changed what the answer was. So if you're confused about that and you already did 6.6, come see me at AOR Extensions. If you haven't done 6.6 yet, you're totally fine. It's good now. All the issues are worked out. So if I do Ford's votes divided by the total electoral college votes, I get 0.44609, and that's about as far as I care to write my decimal out. There's more decimal values, but we don't really care about them. I then, to turn it into a percent, have to multiply by 100, and that gives me approximately 44.61%. Did he win? No. Now, the other way we could have looked at this is if I compare 240 to 538, and I say, well, Ford needs more than 50% of the votes. I could then ask myself, what is 50% of the vote? Well, I know 50% is 0.5, or I can divide by 2. The vote is a total possible 538. So to win, you would need 269, I want to say, is half of 538. Yep. So you would need more than that. So you would need 270 or more. If you have 269, you exactly have 50%, which has never happened that the Electoral College splits perfectly 50-50. So if that happened, they'd have to go back and do a recount and they've done recounts because it's been so close, but it's never been a 50-50 split. Abby?
So this kind of reminds me of something like when you said 269, you would want it to be 270. It kind of reminded me of something.
Was it the Skittles problem?
What?
Okay, what did it remind you of?
It was when you go to the store, but you see something that's $2.99, but it's actually
Right.
$3.
Well, no, it's not actually $3.
Well,
It might as well be $3.
Do they want to give you a penny back?
No, but this comes down to a mental trick. Your brain knows when values are more than other values. When you start reading a price, the first thing you say, your brain clings on to. So when you say the price is $2.99, your brain's thinking about the 2. As opposed to if you made the price $3, your brain thinks that's more expensive than $2.99. It is. It's only a penny more expensive, but your brain makes them seem very different. That's like somebody saying, get this product for only 5 payments of $39.99. You're like, sweet, $39. But really it's $40, and really it's 5 times over. So that's honestly going to be $200. But they give it to you in a way that makes it sound a lot cheaper. Justin? See, so that's what people have asked, and I'm not quite certain why the Electoral College is an even number. There has to be a reason, right? Because the easy answer is make it an odd number. So I'd be curious if you want to research it, find out why did they make it an even number. I don't know. Huh? There you go. Well, I don't know if that'd be a full discovery day, unless you wanted to go deep into like how the Electoral College works, what percent of the votes does each state get, what like how many people equals one electoral vote, because so many people votes, like popular votes, equal one Electoral College vote. So like yeah. So let's say we were all voting, like maybe 15 of us would equal one electoral vote. But really, like when you look at it state-wise, we're talking thousands of people equal one electoral vote. On an 85 question exam, let's say you are back in the traditional school, you're in high school, someone who grades letter grades based off percents. You get 71 questions correct. Okay, decent. The exam had 85 questions, you got 71 correct. What percent did the student score on this exam? So to find out my exam score, Joe, what am I going to do? How do I take this and turn it into a percent? So what we need to write down first, and especially if you're struggling to start this, our percent is always the partial value, or the part, over the whole value, and then we multiply by 100 to turn this into percent form. So write this down. Then the part and the whole. Mr. Surface, what's my part here?
Well, your part is 71.
And the total number of questions on the exam?
85.
85. So I momentarily forget about the times 100. It's just distracting. I can't think. I momentarily forget about the times 100. I do my division, get it in decimal form. Xavier, what was your decimal form here?
83529.
That's good. Well, yeah, we'll put the 9. Then we do our times 100, which really just moves my decimal 2 places, and this becomes 83.53 if I round it percent. Depending on how that teacher grades, that would either be a B or a C, depending on how their grade scale is set up. Yes.
So if you rounded it, like if you wanted to not have that 3 in there, wouldn't it just be 85 and a half?
83 and a half. Yes.
83 and a half points.
So if I told you round to the 10th place, it'd be just the 0.5. If I told you the 100th place, then it would be the 3. If I told you the 1000th place, it'd be 529.
And if you rounded just the whole thing, wouldn't it
Be 84. Yeah. So if this teacher only talked about whole percent values, this would be approximately 84% if we rounded all the way to whole percent value. Any questions on that? Now, this gets really tricky when teachers grade like this, because that's assuming every question is worth the same amount. So when I have your mastery exams, which by the way, so to say it out loud, your progressing to mastery for chapter 5 is right here. I'm not handing them out to everybody. If you need one, grab one at your convenience. Now, who knows what needs to be turned in, like how you turn in the progressing to mastery? Because you don't, somebody this morning was like, you put your name on it, you turn it in. I said, well, hopefully you put your name on it, but there's more. Casey? And the corrections. Now these corrections, if you can't do them, I will do them for you. But you need to come ask. So the corrections need to be done because you'll recognize there are 10 questions on that progressing to mastery. They look very, very, very similar to the original test questions. So you do those corrections so you know what mistakes you made and so that you can do the progressing to mastery accurately. If you only turn in your progressing to mastery, I'm going to give it right back to you because I need to see the original assessment and that you did corrections. You can use your friends to do corrections. Like, you can ask a friend, like, let's say Jack goes to Jaheim and says, hey, Jaheim, did you get number 5 right on the chapter 5 test? He's like, yeah. So can you explain what you did to me, and can I write that down? That's fine. I don't mind that you do that. What I do mind is if you said, hey, Jaheim, can I see your test? And you copy down the answer. Like, that's not really doing corrections. That's not going to help you. And I'm going to know on your progression to mastery that you still don't know what you're doing. Any questions about the progressive mastery? Sweet. So, let's talk about Phoenix. How many of you, and there was one person that I've seen so far, can make the W. How many of you can roll your tongue? Like you. So, they did a study. They actually studied this. And a lot of times, they'll do these studies in malls. So I think that's biased to people that go to the mall. But they will like grab people as they walk by. And that's called a simple random sample. When you just randomly grab people and ask them a question. They asked them, can you roll your tongue? And they found out that based off the study they did, 64% of the people can roll their tongue. Can anyone do the W? Yeah? Can you show us? Oh, it's so weird. So that has that everybody's body is unique to how your body developed, which is why we can all... My sister can bend her elbows backwards. Yeah. Like, it goes a good, 10 degrees. Further. Like this angle, but backwards. Yeah.
I can almost do that.
Bring it back.
I can do that.
Bring it back. Approximately 7th and 8th grade, how many students do we have in Phoenix? 160 is very close. We have approximately 85 7th graders. I got to check if it's 85 or 86. I think it's 85. It's normally our max. But, so we actually normally say that we have about 165 students. We normally have about 82 or 83 in each class. So it adds up to about 165. So write the ratio. Ooh, we're going to need to write the ratio of students who can roll their tongue compared to the total. So obviously our total is 165. So that's going to be the easy part of our ratio. What we're trying to figure out is how many students can roll their tongue. So ratio is just a comparison of two numbers. We can write it 3 different ways. The way we normally write it is with our colon. So we want to compute 64% of Phoenix. How do I do this, Anthony? We've talked. Grace, how do I do this? I want to calculate 64% of Phoenix. Yeah, but what do I have to do to the percent first? Ooh, other way. Divide by the 100. Now, you would realize this very quickly. Because if you multiply by 100, you get 6,400. And when you multiply that by 165, you would realize, like, I've made some epic mistake. Because you would get thousands of students, and that would not make sense. So this becomes 0.64 when we divide by the 100. So then to find my number of students or my parts, I'm going to take the rate value, the decimal value, multiply it by the number of students. Anyone with a calculator handy have this? What do you got, Shane? 105.6. Now, aside from if we have a partial student, we would need to round this to approximately 106. So, 106 students can roll their tongue compared to a total 165. So a ratio is just a comparison of two numbers. We've been using ratios this entire time we've been doing percents. Because when you divide two numbers, you've set up a ratio. So any division problem really is a ratio problem. So now we see that a koala sleeps for 75% of the day. What a lazy animal. Write the ratio of hours the koala is asleep to the total number of hours in the day. Now, you can solve this many different ways. So try this on your own. There's a lot of right ways to do this. Stick up a hand if you are at all confused. So you're doing the fraction way? So we have a couple different ways that we can approach this. We can either change our 75% into a decimal form and then multiply that by the hours. Ooh, I about lost my coffee. We're good. Alright. I know, that's the danger. So, that's one way we can do it. Or we can look at 75% and deal with it as a fraction. If you look at 75% as a fraction, what would that be? It's 3/4, right? So what we actually find out is the quality is going to sleep 3/4 of the day. So the first thing we do is solve for a fourth by dividing by 4, and then multiply by 3 to find out what 3/4 is. And that's how we're going to take up here. So hang on, we're going to do this together. All right. So I was chatting with some people about the multiple ways that we can do this. And 75% is a nice percent. We like it. It is our friend. CJ, you about jumped out of your chair. Why is 75% a nice percent? It's easy to divide. What do you mean? What's 75% turn into? James, what is it? 3/4, right? Because 75% would be 75 over 100. That's what percent tells me. And it reduces to 3/4. So really the koala sleeps for 3/4 of his day. What a lame dude. Justin? Is it this way or is it a different way?
It's similar. I did it with fractions.
Okay, so I have apprehension, but go ahead.
Alright, so because we have 24 hours in a day, we're trying to get 75% of that. 24 is 100%. So if we find like how many times or what takes 4 times to get to 24, then that's our answer.
So I agree with you completely. 100% agree with what Justin said. He just kind of thought about it a different way, which is the whole many right ways to get to Florida. I was about to say, if we want 3/4, make your life easy and ask what is 1/4 first, which is what Justin said he did. 1/4 of the day is how many hours? Well, 1/4 of the day is going to be 1/4 times 24, or 24 divided by 4, which comes out to be 6.
Wait,
But that's 1/4. So to find 3/4, we're going to do 3/4 times 6, or sorry, 3 times 6, since 6 was our 1/4, and that gives me 18 hours that the koala is sleeping. But that's not my answer because it asked me to write the ratio, so it's going to be 18 compared to, or related to the total number of hours, which hopefully we all know is 24. And we would not reduce that since it asked me for total number of hours. Yeah. Yeah. That's another way. The other way is the straight math that we've been doing, where we just convert this to a decimal and then multiply it by the whole, which is 24, and that gives me 18. So depending on how your brain works, depends on which of these you think is easier. Remember, easy is a relative term that is relative to your brain. Come on, capture. So I just have another reminder here of how we do all this. Fraction to decimal, fraction to percent, decimal to fraction, decimal to percent, all of those conversion processes. So last thing we want to do right here is fill in this table. I want you to try to fill in as many of these values as possible. These fractions will be our reduced fractions. So for this decimal, how do I read that decimal properly? Atticus. How do I read this the right way? We don't say 0.12. We say 12. How many decimal place values is this using? 2. What's the second decimal value? So the first one's tenths. Is hundredths, right? So this is 12 hundredths. I reduce that. I can divide by 2 on top and bottom. Get 6/50ths, but I can divide by 2 again and get 3/25ths. But from this decimal, if I just multiply by 100, I get 12%. We will finish out this table to start class tomorrow and then dive into our last section of the chapter.
No.
Oh, here's another weird one. Can you do this?
Yeah, so I did that.
Change from the middles. No, change.
Oh, yeah.
Go back and forth.
Oh, I can't do that. No.
That takes and can you do it left hand?
Oh, no.
It's harder.
Wait, I can do it
Weird.
right
Yeah, back bending.
Yes, I can back bend my finger.
All right, thank you guys. Have a great day. Do not mess with your body too much.